Well, hey there, this is Mrs. Sharp, and I'm going to quickly go through the gold foil experiment with you today. This is the second half of your notes for Learning Target 3.2. Talked about the cathode ray tube experiment earlier. Now we're going to talk about the gold foil experiment. And right off the bat, I think that this term up here that says discovery of the proton is a lot misleading. This should really say the discovery of the nucleus, because Ernest Rutherford, who's shown here in this picture, with this experiment, did not necessarily discover the proton. He did, as we will find, discover that there was a nucleus in the atom and that it had a positive charge, but he did not actually discover the source of that positive charge, which were the existence of these protons. So why don't you go ahead and cross this out in your notes and replace that with nucleus. You have this picture in your notes. This is a picture of the setup of the gold foil experiment. So let's go through and kind of look at what happened. Number one, this radioactive source in the black box has alpha particles in it that shot positive particles at a thin gold sheet. So these alpha particles are positive particles that were from a radioactive source. So I want you to know that these alpha particles being shot here have a positive charge. Most of those positive particles, as you can see here, passed right through the foil. So this very thin gold foil is more like a gold leaf almost, or like very thin gold tissue paper. Behind it was the screen that would record where those alpha particles ended up. So it would leave a little mark in the screen and you could see the path that they took. So most of them, and this is about 99.9% of those particles, passed right through that foil or were deflected at very small angles. And that was actually what Rutherford expected. He expected that most of them would end up right on the other side. Remember, he was testing the previous model of the atom, which was plum pudding, where the atom was solid and had those electrons embedded on the outside. If that was true, he figured that those alpha particles would just pass right through and end up on the other side. However, what he noticed is that some, and this is very small number, bounced back at these wide angles, which you can see here and over here to the left, and that was weird. That made Rutherford think that something wasn't quite right with the plum pudding model of the atom. So here are some results. Number one, Rutherford concluded that plum pudding was wrong. He didn't say it was gross. We say it's gross. Again, there's a picture of plum pudding. You can see it's got the electrons, which will be your plums, stuck on the outside of the solid sphere. Here is a cross section. If we cut the atom in half, you see it's solid. This purple portion would be a positive charge that's weakly dispersed, spread out. And then you've got these electrons embedded in the outside. Rutherford said, number two, that atoms are mostly empty space. And he said that because of the fact that 99.9% of those alpha particles went straight through. Finally, he said that the atom's positive charge is in a small dense center area called the nucleus. And that's where almost all the mass is. So he figured that if most of these particles were going straight through, they must not be hitting anything to deflect them. So that's where he came up with this number two, that atoms are mostly empty space. So since most of them were going through, he figured there must not really be anything for those alpha particles to hit. Number three is the positive charge came from the fact that when they did hit something, they bounced almost straight back, meaning they were repelled. So whatever they were hitting must be very small, because the odds were very small that the alpha particles would hit it in the first place. So it wasn't likely the alpha particles would hit it. And then when it did hit that thing, it got repelled in the other direction, which meant it must be positive. So instead of having like here where you had a wide spread out positive charge, you have like the picture you see in your notes in the lower right hand corner, where that positive charge is just in a tiny little spot in the middle. Most of the atom is empty space except for this very, very, very tiny sphere in the middle that has a positive charge, which we now know as the nucleus. So again, Rutherford did not discover the proton, but he did discover the nucleus and the fact that it has a positive charge. So that's the gold foil experiment. What you can see here is more like what you would think of when you see an atom, where you have a teeny tiny nucleus in the center and it has a positive charge. Now, Rutherford, this is the Rutherford atom. Rutherford did not know about protons and neutrons here. He just knew that this nucleus was positive. So you can see that most of the atom is empty space, and then you have this teeny tiny overall positive in the middle. So if you think of an alpha particle being shot through here, most of them should just pass straight through because this is empty space. But if one happens to hit the nucleus and it's positive, it's going to bounce back and be repelled. And this drawing right here is not even to scale. Really, if this were the size of your nucleus, your electrons would be way off the page here. So this is not a very good scale either. So the nucleus is even tinier in comparison to the entire atom. So there you go. I hope you enjoyed learning about the gold foil experiment. Have a good day.